Good afternoon, everyone. Today, I'm excited to introduce our Mechatronics project titled Automated Waste Classification System, Enhancing Recycling Efficiency and Waste Management. Before I dig into our project, let's meet our members, which are Stephen, Li Chenyet, Chang Zhenyang, Liao Jiahao, and Danny. In today's world, waste management is a critical concern due to its environmental and public health impacts. Traditional manual waste sorting methods are inefficient and error-prone, leading to improper disposal practices. Automation through PLC offers a systematic and reliable solution to optimize waste segregation processes. PLC integration enhancing speed and accuracy while minimizing human intervention. This promotes sustainability by facilitating effective recycling and disposal of waste materials. The project involves automating the waste segregation process, starting from waste collection to sorting using PLC technology. The goal is to create cleaner and more eco-friendly communities for future generations. For the problem statement in our project, manual sorting methods are proving inefficient, labor-intensive, time-consuming, and prone to error. This not only leads to improper waste disposal, but also poses significant health risks to workers. Traditional systems struggle to effectively sort waste materials, hindering recycling efforts and contributing to environmental degradation. So here comes the 4 objectives of our project. The first one is develop an automated waste segregation system integrating PLC technology. Second is design an efficient system capable of segregating different types of waste materials without the need for manual oversight. And the third one will be implement PLC to automate the movement of waste along conveyor belts and facilitating the sorting mechanisms. And the last one is enhance waste management practices by deploying PLC to improve the efficiency and accuracy of the system. Our design focuses on automating waste sorting processes, reducing the need for manual labor and cutting down on associated costs. Central to our system is a conveyor belt equipped with sensors that detect waste items and trigger brief pauses in its movement to facilitate sorting. This innovative approach not only streamlines operation, but also contributes to sustainable waste management practices by minimizing environmental pollution. By leveraging technology to optimize waste segregation, our project aims to create a more efficient and environmentally friendly solution for the waste management.
Good afternoon, Doctor. My name is Steven, and I will be explaining the waste classification flow and also the ladder diagram of our design project. First, we start with the waste classification flowchart. When the start button is pressed, the conveyor belt will be turned on for the rubbish to be moved, and either one of the sensors will detect the rubbish, and the conveyor belt will stop for the hydraulic cylinder to push the rubbish into respective bin. After that, the conveyor belt will resume the operation for the next rubbish to be classified into the bin. And after all the operation is done, stop button is pressed to stop all the operations. And next, I will explain more detail in the ladder diagram. And I will explaining the PLC ladder diagram part for our project, which is an automated waste classification system. So first of all, the components of the ladder diagram include a start button, a stop button, a conveyor, and 4 detection sensors for wet rubbish, metal, plastic, glass, and paper rubbish, and also 4 separately hydraulic cylinder and 4 separate timer, and also 4 separated internal relay sensor. So first of all, when the start button is turned on, the conveyor belt will be activated and run. So the conveyor belt will be latched to the first run so that it can be continue running when the start button is turned off. So the conveyor will continue to run until the first rubbish is detected. So for example, if the first rubbish detected is a wet rubbish, so this moisture sensor will be turned on. So when the sensor is turned on, you can see that the conveyor belt stop to run for the classification job to be done. So the hydraulic cylinder 1 will be activated to push the wet rubbish into the respective dustbin, and a timer of 10 seconds will run simultaneously. So you can see that after 10 seconds, the timer 1 quick switch will be turned on, and the IR sensor 1 coil is activated. So we latch the IR sensor 1 switch to the first run, so that when the IR sensor 1 coil is turned on, the IR sensor 1 open switch will be closed, and for the conveyor to be continued to run. So after the first rubbish is sent into the dustbin, so the wet rubbish sensor will turn off. So the conveyor will continue to run until the second rubbish is detected. So for example, the second rubbish detected is metal type, so the metal detection sensor will be turned on. So you can see that the conveyor stopped again for the operation to be done. So you can see here, the hydraulic cylinder 2 is turned on, and the timer 2 for 10 seconds is turned on simultaneously. So after the metal rubbish is pushed by the hydraulic cylinder into the dustbin, the IR sensor 2 coil will be activated again. So we latch the IR sensor 2 to the first run, so that when the rubbish is finished to be pushed into the dustbin, the conveyor belt will start to run again, and the metal detection sensor will turn off. So next, we assume that the third rubbish received is a plastic rubbish. So the plastic rubbish sensor will be turned on. You can see that when the plastic detection sensor is turned on, the hydraulic cylinder 3 is also activated to push the rubbish into the dustbin, and a timer of 10 seconds is turned on simultaneously. So when 10 seconds passes, the timer 3 quick switch will be activated. So you can see that the IR internal relay sensor 3 coil is also turned on, and we also latch the IR sensor 3 open switch to the first run. So when the IR sensor 3 coil is activated, this switch will be closed for the conveyor to continue to run. And last is the glass and paper rubbish. So when the glass and paper detection sensor is turned on, hydraulic cylinder 4 is also turned on for 10, and then a timer 4 of 10 seconds is turned on simultaneously for the operation. So you can see that after 10 seconds, timer 4 quick switch is activated, and IR sensor 4 coil is activated, meaning that the process of pushing the rubbish into the glass and paper classified bin is done, and then the conveyor will continue to run. And this process is repeated continuously until all the rubbish are classified into their respective bins. And after all the operations and all the processes are done, we click the stop button to turn off the whole system.
Hello everyone, today we are dividing into the realm of waste management and how advanced sensor technology in the ladder diagram is evolutionizing the sorting process. Let's start by understanding the backbone of this innovation, the sensors. We have an array of them at work here. In our automated waste sorting system, we use various sensors to make the process smoother and more accurate. The IR sensor turns on the conveyor belt and when it detects something, saving energy and reducing wear on the machine. The moisture sensor helps us tell if waste is dry or wet, which is important for deciding if it should be composted or burned. The inductive proximity sensor separates metal from non-metal waste, which is crucial for recycling. Additionally, the capacitive proximity sensor identifies clear plastic bottles and helps sort plastic, glass for recycling or disposal. Together, these sensors ensure precise sorting, making our waste management more efficient and reducing contamination. Now, let's talk about the real-world impact. Automated sorting speeds up the process, slashing process time compared to manual methods, which will increase in efficiency. For resource recovery, accurate segregation enhances resource recovery, fostering the circular economy and reducing raw material extraction. For environmental benefits, proper sorting minimizes landfill usage and pollution, conserving precious natural resources. Lastly, for consistency and accuracy, automated systems ensure precise sorting, improving the quality of recycled materials and potentially boost market demand and prices. In conclusion, the integration of advanced sensor technology into waste sorting system is a game changer. It makes waste management more sustainable, efficient, and environmental friendly. By optimizing sorting process, we are paving a way for a cleaner and greener future. Thank you. Now, I'll pass the floor to Liao Jiahao.
Thank you, Chan Zhongyang. Good day to everyone. This is Liao Jiahao presenting on the impact to business. The first impact is the cost savings. By reducing the labor costs associated with manual sorting and improving operational efficiency, business can achieve significant cost savings in waste management operations. This allows the business to allocate resources more effectively and invest in other areas of operation or expansion. Second impact is the increased revenue opportunities. Proper waste classification, facilitated by the automated system, ensures that the valuable recyclable materials are recovered and diverted for recycling. This means the opportunities for business to generate additional revenue through the sale of recycled materials, and furthermore, business can potentially attract environmentally conscious customers and partners by demonstrating their commitment to sustainable practices. The third impact is the enhanced compliance and reputation. Implementing advanced waste classification technology demonstrates a commitment to environmental responsibility and compliance with waste management regulations. This can enhance the reputation of business within their industries and communities, leading to increased trust and credibility among the stakeholders, including the customers, investors, and regulatory authorities. And the last impact is the improved operational efficiency. Automation streamlines the waste classification process, leading to improved operational efficiency and productivity. Business can handle larger volumes of waste more effectively, reducing the bottlenecks and delays in waste management operations. This improves the efficiency and enables the business to meet growing demand for waste management services and adapt to changing market conditions more effectively. Overall, the implementation of an automated waste classification system by using the PLC technology presents these significant opportunities for the business. By embracing innovative technologies and sustainable practices, businesses can position themselves for long-term success in a rapidly evolving waste management landscape. That's all from me. Thank you.
So for conclusion, the first point will be provide effective and dependable solution for categorizing a wide range of waste material, including glass bottle, plastic, paper, and biodegradable trash. And then the second one will be decrease dependency on human labor, lower mistake in categorizations, and improve the speed and precision of the sorting procedure. And finally is to reduce the risk of occupational hazard related to manual sorting, therefore guarantee the safety of worker in surrounding that may be dangerous. And for recommendation is to improve waste management method. It is crucial to prioritize the incorporation of modern sensor technology. This will enhance the precision and dependability of automated waste segregation system. Furthermore, it is important to promote continuous research and development in order to tackle current obstacle and enhance sorting method. Collaborative that involve academic, industrial, and environment agency are crucial for promoting innovations and enhancing overall efficiency and separation rate. Furthermore, it is essential to give priority to worker training and safety regulation in order to protect against potential danger linked to automated garbage sorting. By offering extensive training program and enforcing strict safety protocol, the welfare of employee can be guaranteed while maximizing system efficiency.